Okay, so to begin section 3.1, parallel lines and transversals, we first want to define some of our previous terms. So skew lines, does anybody remember what skew lines are?
Yeah.
What?
They're not coplanar.
Yes, skew lines are lines that are not coplanar. And it's going to do this the whole time. Lines that are not. I can't rest my hand or it messes this whole document up. So my handwriting is going to be awful, but we'll try. Okay, what are parallel lines? What are parallel lines? So they don't what? Right. So these are coplanar lines that do not intersect. They're about as opposite from skew lines as you can possibly get. Coplanar lines that do not intersect. I have to rest my hand in it. I don't know why that does that every time. I'll do that. Okay. What are supplementary angles? Angles whose sum, oh, it's going to be like that. All right, hold on. All right, angles whose sum equals 180 degrees. Yes. What are complementary angles? Their sum equals what? Complementary is 90 degrees. Thank you, Ava. 90 degrees. And then supplementary angles are straight line. They're 180 degrees. Okay. So parallel lines have already been defined as coplanar lines that do not intersect. Mathematicians have given names to special angles that are formed when two or more coplanar lines are intersected by another line called a transversal. And instead of having you guys not make another note card, even though I would ask you to, I guarantee you will have it. I went ahead and put it on your worksheet for this one instance. We will be making note cards for the theorems that are in this section. But let me go ahead and get a PowerPoint. Let's see, 3.1. Come on, you can do it. There we go. All right, new share. Okay, so for this is the definition of a transversal. We've got the diagram of one on the side, and you've also got that on your worksheet. It should be pretty similar. Yep. All right, so a transversal is a line that intersects two or more coplanar lines in more than one point. Okay, so what are the two coplanar lines that we're looking at in this diagram? I mean, we do have three, but only one is intersecting both of them. So which line here is the transversal? Line T. Therefore, what are the two coplanar lines that they're intersecting? That transversal is intersecting? Right, we've got line L and we've got line M. And they are coplanar because they're not like on two completely separate planes. They're on one flat two-dimensional plane. And the transversal is intersecting both of them. Now, L and M, are they parallel? No, they are not. So that helps a little bit. So eventually they will intersect, but right now we're not worrying about that intersection. But we still know things about these two lines and then the angles created by the intersection of this transversal. So there are four different types of angles you need to make sure that you understand and know how they compare to each other. So the first type of angle is corresponding. Corresponding angles are on the same side of the transversal and the same side of the other two lines. So for example, angle 1 and angle 3 are corresponding. Angle 5 and angle 7 are corresponding. 2 and 4 are corresponding, and 6 and 8 are corresponding. So they're on the same side of the transversal. So for example, 1 and 3 are both on top, or excuse me, are on the left side of the transversal, and they're on the same side of the other two lines. They're both on top. So they take up that they take up the northwest quadrant of both of these intersections, right? And the same thing with 5, 7, 6, 8, and 2 and 4. So those are called corresponding angles. Alternate exterior angles are on opposite sides of the transversal and outside the other line. So do we understand how the two lines L and M, the top of line L and the bottom of line M are the outside of those lines? Does that make sense to all of you? Why that's outside? Whereas the inside is what we call the bottom of line L and the top of line M, that's inside, right? Because it's inside the boundary created by those two lines. So that's what they mean by outside and inside of angles. So the alternate exterior angles, they are exterior because they are on opposite sides of the transversal. So 1 and 8. So think northwest and southeast, southwest and northeast, right? So those are going to be alternate exterior. The alternate interior are on opposite sides of the transversal and between the other lines. So that's 2 and 7 and 6 and 3. Right? Okay. And then your last one is the consecutive interior, the same side of the transversal and between the other lines. So 2 and 3 and 6 and 7. Now, the reason it is so important to understand what corresponding alternate exterior, alternate interior, and consecutive interior mean is because the theorems will explain what these angles are related to each other. Because like, for example, so Gabe, if we looked at 1 and 5, what is the sum of those two angles? They're just number 1 and number 5. What do you know the sum of those two angle measurements are? Yeah, 180. How do you know that? Because they're supplementary angles. Now, in this case, they're also a linear pair, right? They're connected. They share that transversal as one of their sides. So they're a linear pair, which means they are both adjacent and supplementary. But that's why we kind of refreshed on supplementary, because if I gave you a measurement for angle 1, you could tell me the measurement for angle 2 and angle 5, either one that I asked you for, because 1 and 2 are 180, 1 and 5 are 180, and 1 and 6 are equal, and 2 and 5 are equal, right? Because they're what kind of angles? What are 2 and 5 compared to each other? What do we call those? They are not adjacent. They do not share a side. 2 and 5. What are they? Vertical angles. Yes. And vertical angles always have the same measurement when two lines intersect. So they create vertical angles. All right. Just a little extra. You don't have to pay me for that one. Little review. I know, right? Oh, I'm sorry. Do you want me to keep that up there? It's right there in your book too. And hopefully I even gave Andrew enough room to write on it. Who knows? I do need to go ahead and move on, but you do have that. You have that as an option. Okay, so we have angle postulates and theorems coming up. Corresponding angle postulate. Who wants some note cards? I need note cards. I need you guys to make note cards for this section. So if you need note cards, I'll make sure I get you some. You want to go ahead and get some now?
I can put mine.
You don't have to do them in class today. I just want to make sure everybody has some.
I have no
I have note cards. If you need more. Again, y'all need something good. Yeah, see, those are probably a better size. All right, make note cards for each of these. Let's talk about this note card business. So on one side of your note card, okay, good. Let's talk about what this note card needs to look like. So on one side of your note card, you have your Or I am not entirely sure I'm writing that right, but I think it's 1O. Corresponding angle postulate which reads, if two parallel lines are cut by a transversal, the corresponding angles are congruent. So if two parallel lines are cut by a transversal, trying to hurry in, I'm doing bad, are cut by a transversal, then the corresponding angles are congruent. All right, and then the flip side of the other side of your note card. Let's see, corresponding angle postulate. You could use the other example that they give you. Let's talk again about notation here. So look at example 1. So what could go on the other side here is that we have, of course, you're going to have lines, maybe. You've got two lines here and here, and then cut a transversal through them. Now, I want y'all to notice something. This red arrow that they have, if you see this on a quiz test or example, that is telling you that those two lines are parallel. And so this means, so if we label it T, line L, line M, I'm gonna go 1, 2, 3, 4, 5, 6, 7, 8. Then your corresponding angles, which are on the same side of the transversal, same side of the other lines. So that means that the measurement of angle 1 is equal to the measurement of angle 3. You can give yourself any kind of example how you want to. Measurement of angle 5 is equal to the measurement of what angle? We know 5 is going to be equal to what? What's 5's corresponding angle? 7. The measurement of angle 3, no, I already did that one. That's 1 and 3. Measurement of angle 4. Yep, is equal to the measurement of angle 2. So if you know 4, you also know 2. If you're told that they're parallel. If you know 4, you know the measurement of angle 8, the measurement of all the other ones. All you need is one angle measurement, right? Because you've got supplementary angles. 4 and 8 are supplementary. 4 and 3 are supplementary. 4 and 2 are equal because they're corresponding. And therefore, if you know 4, you know 2. And if you know 2, you know 1. And if you know 1, you know 5. And if you know 5, you know 6. So you see how all you need to know is that these two lines are parallel and one of the angle measurements, and you therefore know every other angle measurement. Do y'all recognize that? See what I'm talking about? Because you know what supplementary means, because you know the corresponding angle postulate, it tells you if line L and M are parallel, then 4 and 2 are equal, 1 and 3 are equal, 5 and 7 are equal, and 8 and 6 are equal. Okay, so this is what your note card needs to say. And you could even put, that line L is parallel to line M. And that's what those red marks mean. So this is what your note cards need to look like in order for them to be valuable to you going forward, solving the rest of the geometry as we move through here. So you need to have a note card for all the rest of the theorems. You have the alternate exterior angle theorem, interior angle theorem, consecutive interior angle theorem, and the perpendicular transversal theorem. And at least get those written down, and we will work on some examples if you end up needing them. All right, so let's go ahead and go through the rest of the examples that we have here. So here it is. Okay, so for example 1, they want us to find the measurement of each angle if the measurement of angle 4 is 53 degrees. So let's go ahead and do that. I'm going to use my, come on. I wonder if I can do this. Yep. I guess he'll be watching this video from home too. Okay, let me copy that. Yeah, that's fine. As long as it's useful to you. Okay, so what did they tell us? They told us that angle 4. So the measurement of angle 4, that's not right, is 53 degrees. All right, so what is the measurement of angle 3? Chad? If I know, I'm just doing this. If the measurement of angle 4 is 53 degrees, what is the measurement of angle 3? What do I need to do to find that angle measurement? 180 minus 53, which gives me what? 10 take away. That's a 7 and that's a 10. So 10 take away 3 is, I'm recording, so y'all try to be as quiet as possible, please. 10 take away 3 is 7, and 17 take away 5 is 8. No, wait, 12. Why was that so hard? I don't know. I lost it there for a second. Yes. Yeah. So the measurement of angle 3 is 127 degrees. All right. So Gabe, what's the measurement of angle 2? Yeah. If the measurement of angle 4 is 53, what's the measurement of angle 2? You'll be all right. Just maybe some paper. And I gave you a worksheet, so you can write some of this on the back of it if you want. What do we know about angle 4 and angle 2? Mm-hmm. No. This is what we've been talking about. They're congruent. They're the same. Corresponding angles, when you have parallel lines, are the same. So if angle 4 is 53 degrees, what is angle 2? 53 degrees. Yes. All right. So what is angle 8, Aiden? From what? Yep. Or we know angle 3. What else tells us that angle 3 and angle 8 are the same? That they're congruent. Because they're vertical angles. Yes. So if we calculate angle 3, we know that angle 8 is 127 degrees. Or if we know that angle 4 and angle 8 are supplementary, then they equal 180 degrees. So we can subtract 53 from 180. And that also gives us angle 8. So Ava, what about angle 6? Yes, so the measurement of angle 6 is, you could subtract 53 from 180. And how do you know that you're subtracting 56 or 53? Yep, it's a supplementary angle to angle 2, which we've already, yes. So 6, we know that 6 plus 2 is going to equal 180, or angle 6 plus angle 2. So yes, so again, it's 127. All right, so do y'all see now how knowing that they are parallel, and let's see, knowing that they're parallel, that line L and line M are parallel, then the corresponding angles to tell us what the, like we know that 4 and 2 are the same because they're corresponding angles. Okay, so let's go ahead and look at the alternate exterior angle theorem. So again, they've given you that, they give you the theorem on page 109. So if two parallel lines are cut by a transversal, then the alternate exterior angles are also congruent. Now, we also just proved that, right? So which ones are the alternate exterior angles? Right, so 1 and 8, and then 4 and 5. Which if you see here, when we measurement of angle 2 was 53, so you know the measurement of angle 1 is 127. And that is also equal to the measurement of angle 8. Angle 4 is 53, so angle 5 is also going to be 53 degrees. So on your note card, you would have alternate exterior angle theorem and the written definition, or if you've got one of these bigger ones, you can fit the whole thing on there. And then use that example at the bottom. I'm just gonna, let's see, I wonder if I can erase without like totally demolishing this thing. Probably not. Oh, so bad. That's T. This is 1, 2, 3, 4, 8, and 5. Okay. So if you have that same diagram written with the alternate exterior angle theorem, that tells you that the measurement of angle 1 is equal to the measurement of angle 8, and the measurement of angle 4 is equal to the measurement of angle 5. If line L is parallel to line M. So again, here's your example. That's the same one you've got right there underneath it. And they're asking us to prove it. So the statement is, if A is parallel to B with transversal T, prove that angle 1 is congruent to angle 8. So you start with your given, and then angle 1 we know is congruent to angle 3 because of the corresponding angle postulate. And we know that angle 3 is congruent to angle 8 because of the vertical angle theorem. You could also say definition of vertical angles. I'll always take that too. And then you use the transitive property of congruent angles to then substitute that angle 3 with angle 8 to say that angle 1 is congruent to angle 8. And so that's how you prove those. All right, let's look at more. So the alternate interior angle theorem, if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So which one are the alternate interior angles here? 2 and 7, 3 and 6. Does that make sense? Yeah, okay, sounds good. I think I might have mentioned something like that in the video. Yeah. Okay, so yeah, so 2 and 7 are interior because they're inside our parallel lines. They're inside our coplanar lines. 1 and 5 and 4 and 8 are exterior, but they're supplementary. So there's exterior, I'm losing it. Exterior alternate angles. The 1 and 8 and the 4 and 5 are exterior. 2 and 7 and 3 and 6 are interior. And so you would have this on your note card, and then with your diagram, you would want to kind of state 2 and 7 are congruent, or their measurements are equal, and the measurements of angle 3 and angle 6 are equal. All right, consecutive interior angle theorems, or theorem. If two parallel lines are cut by a transversal, then the consecutive interior angles are supplementary. So what are the consecutive interior angles? Consecutive means they're on the same side of the transversal. And interior means they're inside your,
So 6 and 7 and 2 and 3.
exactly. So 2 and 3 are supplementary, which means they equal what? There's some, you gave that same thing earlier. So that means that the sum of those two angle measurements equal what? 180 degrees. So 2 plus 3 is 180. And angle 6 and angle 7 with their measurement of those two angles will equal 180 degrees. You said no. Is that what that was? Okay. All right. And then the last one that you have on page 110 is the perpendicular transversal theorem. This is the last one we're going to talk about. And then hopefully we'll get into some more exercises so you'll have a little less homework tonight. If a transversal is perpendicular to one of two parallel lines, it is perpendicular to the second line also. Hopefully that logically makes sense, but if you have two lines that are parallel, and then it tells you that the transversal is perpendicular to one of two parallel lines, then it would also be perpendicular to the second. Now, the example that we have right now on the screen, is that transversal perpendicular to either of these two lines? No, because what must a line be to be perpendicular to another line? It must create what? What does perpendicular mean?
They're not touching the parallel.
That's parallel.
Yes.
Perpendicular means that it forms a right angle.
Oh.
The intersection of the two lines, and that's also why the symbol for perpendicular is like an upside down T, right? So it means that the intersection of two lines, those two lines are perpendicular if their intersection forms a right angle. Okay, so example 2 is right there at the bottom of page 110, the bottom half of it. So find the measure of each numbered angle if the measurement of angle 1 is 7y minus 15 and the measurement of angle 2 is 10 times y plus 11. I don't necessarily like how they work these out. Yeah. Yeah, go ahead. Let me jot this down. So if I have two, obviously not parallel lines, here we go. Let's try this. So you have two parallel lines. So again, something you'll see in the notebook, or in the video, if there are these little arrows, singular arrows, that's telling you those two lines are parallel. So that is the notation for parallel. And then we have, in this case, we have A, this is line B, this is line C. B and C are parallel, and then we have this third. I'm not going to be able to do that. This is the yes, yes. All right. I know, right? So late. All right, and what does that mean?
Right.
That means that is a right angle, which has a measurement of what? Thank you. Measurement of 90 degrees. All right, so then we have angle 1. Where did 2 go? Oh, there's 2. 2, 3, 4, 5, and 6. Okay, so they have told us that the measurement of angle 1 is equal to 7y minus 15 degrees. And the measurement of angle 2 is 10 times y plus 11 degrees. Obviously, right. All right. So what's that? 10. That's a 10 right here?
Yeah.
That was a 10. All right. So we know that the measurement of angle 2 is equal to angle 3. Why? I've got a migraine. I'm struggling. I'm trying to keep keep it straight. Okay, so we know the measurement angle 2 and the measure is equal to the measurement of angle 3 because they're vertical angles. Now, what about angle 3 and angle 1? What do we know about those two angles?
The word you just used.
These are, they're alternate consecutive interior, right? Yes, we know that they're consecutive interior angles. Consecutive, they're on the same side of the transversal, right? They're both on this side of the transversal, and they're both inside, or they're the interior of our coplanar lines, which is what consecutive interior means. Same side of the transversal and between the other lines. Therefore, we know that the measurement of angle 1 plus the measurement of angle 3 is 180.
Okay.
Yes,
Questions?
yes.
You said those are on the interior?
They're on the interior because they're inside the top and bottom lines. They're inside the
If they're
coplanar
above
lines.
Or below the top. and
If
bottom.
they're up, well, and even if they're side by side, you see, okay, and you missed this part, so you will see it, you'll see it, I think, the two lines that are parallel to each other, those determine interior and exterior. They can be vertical. And then you
It's
have
just if it's on
interior
the
and
sides.
external. Right,
Or
the
on-
line that cuts between them is the transversal.
So depending on what side it is, that's what makes it interior. or
Yes.
exterior.
Yes, if it's between your coplanar lines, then it is interior. If it's outside of those coplanar lines, then it's exterior. No, it has nothing to do with the transversal. And in this case, you're looking at it in terms of the transversal, which is the one cutting through it. So yes, so we know that these are the case because of the consecutive. Oh, it's gonna be difficult. Interior angle theorem. That's a lot. Anyway, so can you see how we can supplement something here? We can use the substitution. Because we know angle 1
No,
and we know angle 2. Where can we plug in angle 2, add it to angle 1 to equal something to solve for our unknown?
well,
Anybody? So
okay,
this is,
oh, wait, okay, let me ask you.
that's what we were given. We're given angle 1 and we're given angle 2.
Angle 1. Okay, so angle 2 is equal to angle 3.
Right, And
And
we-
angle 1 plus angle 3 is 180.
right.
So we can just put the equation to y11 for 3, right? Because we know they're the same.
Well, okay, so substitution tells you that you can then have the measurement of angle 1 plus what equals 180.
Plus 10, or measurement of angle 2, it's the same.
Right.
I was just putting it in.
You were just skipping on to the actual value. Substitute. It should be STITUTION. All right, yeah. So we just substituted angle 2 for angle 3 because we have a value for angle 2. They gave it to us up here. So now we can plug in what they gave us. 7y minus 15 plus 10 times y plus 11 equals 180. And then simplify and solve.
Addition property of quality.
Right, well,
Or
first we need to use the distributive property, right? 7y minus 15, and then 10, that's 10y. And then 10 times 11 is, 110.
and then you find your like terms. whatever that
Mhm.
is.
So 17y, what's 110 minus 15? 95? Okay, plus 95 equals 180.
In your addition property of quality.
Now the equality, yes. That's minus 95 to both sides, which gives me what, 85? 17y. Is it gonna be even? It's gonna be even. I think it is even.
There's no way. this is gonna- Is it?
Because 7 times 5 is 35. So I think it's 5. So this becomes 85. And if you divide both sides, 17 times 5 is 35. Carry my 3, and that's an 8. Yep. Okay, so y equals 5. All right, what did we just solve here?
You solve for y, so now you need to plug in.
Well, hang on, hold on.
right? So now we've got to plug it in. Now they asked us, find the measure of each numbered angle. Okay. So let's go back to our diagram here. So I just solved for y, thank you. I gotta erase here. Okay, so we know the measurement of angle 1 is equal to 7 times 5. No, 7. Yeah, 7 times 5 minus 15. And 7 times 5 is 35, minus 15 is 20. Come on. So this one equals 20 degrees. I need to make that a different color. All right, and the measurement of angle 2. Is that time all right? Oh, not right, not quite. Here we go. Let's get through this one and we'll be okay. Measurement of angle 2 is 10
It's 105, I think.
times 5 plus 11.
It's 50, 11.
Well.
Oh, I was wrong. Never mind.
160.
Yeah.
I'll show you. Okay, so the measurement of angle 2
Wait. Ooh,
is 160,
never mind.
which makes sense, right? I'm sorry, go ahead.
No, I was on the distributed product.
Oh, yeah, well, when you don't have a variable, just solve inside your parentheses. Okay, so we,
3 is the same as-
right,
What that is.
3 is the same as 2, which is, yes, 160. From various things, the vertical angle theorem tells us that, but also, you know, that angle 1 and angle 3 are supplementary. So if angle 1 is 20, then angle 3 must be 160 because they have to equal 120. So what does that tell us about angle 4? It's 20 degrees. So angle 3 and angle 4 are also supplementary. What about 6? Oh boy.
6.
What does our perpendicular transversal theorem tell us?
It's 20 degrees.
If a transversal is perpendicular to 1 or 2 parallel lines, it is perpendicular to the second line also. So that means if line D is perpendicular to line C, it is also perpendicular to line B, which tells us what about the intersection between D and B? The intersection creates
It's a 90 degree.
two 90-degree angles. So this is a 90-degree angle and this is a 90-degree angle. And if angle 1 is, there you go. So if angle 1 is 20 degrees and angle 1 plus angle 6 is 90, then angle 6 must be 70 degrees. And what do we know about angle 5?
What about, I don't know, it's 90 degrees.
Angle 5 is 90 degrees. And I think that's all of our numbered angles, right? 1, 2, 3, 4, 5, 6. Does this make sense? I mean, come on. Do your note cards. Look at the problem that we just did. All right, homework. No.
I don't know where to.
Well, you've got the video. You only missed like the first few minutes of it. You'll be all right. Okay, so these are on page 111. I didn't give you all a whole bunch. This is, I want you to do numbers 1 through 14, number 19, and number 22. You need some practice with those proofs. All of them.
Is there gonna be 14 proofs?
It's not, no, it's 22 is a proof.
Okay.
19 is similar to what we just did. And 1 through 14 is very easy. It's again, like what we just did. Once you solve one, you solve the other, and you've got all of the other ones. You just need to pay attention to which ones are supplementary, which ones are vertical, which ones are corresponding, etc. All right. You guys are dismissed.